The Cyclical Ascent: Understanding the Evolution of Artificial Intelligence. Artificial intelligence, AI, is the science of creating machines capable of performing tasks that typically require human intellect, such as learning, reasoning, and problem-solving. The history of AI is not a linear progression, but rather a series of profound intellectual breakthroughs punctuated by periods of disillusionment, known as AI winters. The evolution of this field demonstrates humanity's persistent quest to replicate intelligence, moving from abstract symbolic logic to data-hungry neural networks that now underpin the digital world. This journey reveals that true progress in AI is not merely about conceptualizing thinking machines, but about accumulating the computational power and data necessary to realize that vision. The formal birth of AI is typically traced back to the 1956 Dartmouth workshop, where the term artificial intelligence was first coined by John McCarthy. This period, characterized by immense optimism, focused primarily on symbolic reasoning, aiming to encode human knowledge and rules into computer programs. Early successes, such as the logic theorist program developed by Alan Newell and Herbert Simon, proved that machines could solve complex mathematical theorems. However, the expectations set by researchers quickly outpaced the available technology. Lacking the necessary processing speed and large-scale memory, these early systems struggled to handle real-world complexity and ambiguity, leading to the first AI winter in the mid-1970s when government funding evaporated due to unmet promises. AI saw a resurgence in the 1980s with the commercial success of expert systems. These programs used large databases of domain-specific rules, often gathered from human specialists, to diagnose problems or configure computer systems. Systems like DEX R1 or XCON proved highly valuable in specific, narrow domains. Crucially, the theoretical foundation of neural networks was also revived during this time, with the introduction of the backpropagation algorithm by researchers like Geoffrey Hinton, which allowed multi-layered networks to learn efficiently. However, the cost and difficulty of maintaining massive expert system databases, combined with the limitations of the hardware available to train complex neural networks, led to the second AI winter throughout the 1990s. AI research continued, but it moved away from grand promises toward niche applications, paving the way for the statistical and computational revolution to come. The true renaissance of AI began in the early 21st century, driven by three pivotal forces: massive datasets, big data, fast and inexpensive processing via graphics processing units, GPUs, and algorithmic innovation. This period is defined by deep learning, a subset of machine learning that utilizes complex, multi-layered neural networks, deep neural networks, to identify patterns in raw data. Milestones like the 2012 ImageNet competition, where AlexNet dramatically reduced the error rate in image recognition, proved the effectiveness of this approach. Subsequent breakthroughs, such as DeepMind's AlphaGo defeating the world champion in the complex game of Go, demonstrated AI's capacity for strategic intuition. Today, the evolution continues with large language models, LLMs, and generative AI, exemplified by models like GPT, which are transforming human interaction and creative work, successfully engaging in human-like dialogue, a goal first proposed by Alan Turing in his seminal 1950 paper, Computing Machinery and Intelligence, where he introduced the concept of the Turing test. The evolution of artificial intelligence is a dynamic story defined by alternating intellectual leaps and practical setbacks. Each cycle, from symbolic logic to expert systems and finally to deep learning, was limited only by the era's available resources. As AI systems become more ubiquitous, the focus of the field is inevitably shifting from mere capability to responsibility. The current phase of evolution is marked by increasing efforts to address complex ethical questions, including bias, transparency, and safety, as researchers simultaneously push toward the ultimate goal of artificial general intelligence, AGI, a machine capable of performing any intellectual task a human being can.